Okay, Algebra OST, topic 6 review on exponents and exponential functions. So again, I don't think they'll have any exponent rule problems on there. You will see some exponential function problems. So here is the general formula. Typically, I like to put that b in parentheses. So f of x equals a times b to the x. Remember, a is going to be your initial value, your y-intercept, and b is that constant ratio that you're multiplying by to change. Again, remember to get this x in the exponent, there is that A-B button in Desmos. Make sure you use that A to the B button, or you can use the caret, on your keyboard. Again, just notice this time that when you're looking at exponential functions, they grow very fast. So instead of being straight lines, they're going to be curves. So if you come down here, right, you can see on one side they approach what is called an asymptote line. Typically, our asymptote line is going to be y equals 0, right? The x-axis. Same thing here, asymptote line, okay? And there you go. But again, if you have to graph it, just use Desmos to graph a exponential function. Now, the one that you will see at least twice, I think, is the growth and decay models. So this is very important here and here. Compound integers, not so much. So if you're growing, that means you're increasing. So this number inside the parenthesis is going to be a 1 plus r. R is the percent that you're growing by, but you have to write it as a decimal. So again, if you're growing by, say, 40%, that would mean 0.40. If you're growing by 4%, that's 0.04, right? So keep that in mind, right, when you're changing a percent to a decimal. But again, here's the growth equation, here's the decay equation. You got to remember, 1 minus r, 1 plus r, growth versus decay. Okay. Graphically, if you look down here, notice that the growth, as you go to the right, your growth is increasing. For decay, as you go to the left, you're not growing. You're approaching that asymptote line, so you're actually decreasing in value. Geometric sequences, again, very important here. Again, this time with a geometric sequence, now you're looking at numbers that don't have a common difference, but have a constant ratio, right, or a common ratio. So for instance, if I look at these numbers here, so it looks like we have a first term of 2, a second term of maybe 8, and then we have a term of 24. Sorry. 1 second. I'm confused. So we have a first term of 2, a second term of 6, 18, 54, and then I believe this one is 162, right? So if this was my sequence of numbers, to find the common ratio, I'd say what times 2 gives me 6, or divide 6 by 2. 6 by 2 is 3. Divide 18 by 6, that's 3, right? And so on. So here, my constant ratio is 3. My first term is 2. So this is the recursive formula. To use the recursive formula, you take the previous term and you multiply by the constant ratio. So say I want to find the fourth term. So to find the fourth term, I take the third term, 18, and multiply it by the constant ratio, and that is 54. So say I want to find the next term. So this is the 1, 2, 3, 4, 5. Let me find the sixth term. I'm going to take 162 and times it by 3. 162 times 3 is a big number. 6, 8, 46. Now we're also the explicit formula right here, right? Explicit formula, function notation f of n equals a sub 1 times the constant ratio to the n minus 1 power, right? And again, this can be used to find any term that I want to find. So I could find the 50th term, the 60th term, the 12th term, whatever you want to do, by plugging in that value for n. So you got to try to remember this formula here. And then I don't think you'll need to know the translations involving exponentials. So from topic 6, right? A couple things to remember. First, the general exponential function f of x equals a times b raised to the x. You have your growth, right? So for growth, so y equals a 1 plus r to the x. Decay, y equals a1 minus r to the x. And then you have your geometric sequence. F of n equals a sub 1 parentheses r to the n minus 1. So these formulas you need to try to remember. So again, we're just adding to our list of formulas to remember for the state test.